Hello there, and welcome to the Sleepy Science Channel. Tonight, we're embarking on a journey to explore one of nature's most awe-inspiring creations, the human body. Within you lies a universe of mysteries, far more than we could ever hope to unravel in a single video. So, if your eyelids begin to feel heavy, don't resist. Allow yourself to drift off to sleep or simply listen for as long as you desire. My hope is that by the time this video concludes, you'll have gained a newfound appreciation for the incredible machine that you inhabit. So join me now as we marvel at the miraculous nature of the human body. Let's begin, shall we? Your body is a bustling metropolis, constantly constructing and renewing itself at an astonishing rate. Every single second, approximately 25 million new cells spring into existence within you. Think about that for a moment. As you lie still, breathing quietly, your body is far from idle. It's a hive of activity, a silent symphony of construction. That equates to roughly 1.5 billion cells every minute. These microscopic builders are quietly dividing, organizing, and differentiating to repair damaged tissue, renew your skin, replenish your blood, and mend the invisible wear and tear that comes with simply being alive. Most of this cellular renewal occurs without you even being aware of it. Bone marrow tirelessly produces fresh red blood cells, ensuring a constant supply of oxygen to every corner of your body. The lining of your gut, constantly bombarded by digestive acids, is renewed in waves, protecting you from self-digestion. In your skin, your protective barrier against the world is in a state of constant turnover. The sheer scale of this regenerative process is almost impossible to comprehend, but it serves as a powerful reminder that beneath the calm surface, your body is a dynamic, ever-changing ecosystem, constantly rebuilding itself in silence. Did you know that you shed an entire layer of skin every single month? Your skin might seem like a static outer shell, but the truth is it's in perpetual motion. Every 28 to 30 days, you shed an entire layer, a process so gradual and subtle that you barely notice it. Dead skin cells drift away invisibly, replaced by newer cells that migrate upward from the deeper layers of your skin. In fact, most of the dust you find in your home is composed of tiny particles of your own skin. Over the course of a year, you lose roughly 8 pounds of it. But don't worry, you never run out. Your skin regenerates with incredible precision, restoring its protective barrier pore by pore. What you touch the world with is constantly changing, a living frontier between you and the vastness of the universe. Consider this. Your stomach regenerates its lining every 3 to 4 days. Your stomach is filled with an acid so potent it could dissolve metal. So, how does it avoid digesting itself? The answer lies in one of the body's most remarkable defense mechanisms. Every 3 to 4 days, your stomach completely regenerates the cells that line its walls. These cells create a protective barrier between your tissues and the hydrochloric acid needed to break down the food you eat. Without this constant renewal, ulcers and severe damage would occur rapidly. This delicate balance between destruction and regeneration is continuous. Even as you sleep, tiny factories within your gut are hard at work, rebuilding your defenses and maintaining a protective layer that is always young, always new, and always just one step ahead of your own digestive processes. Let's delve into the hidden world of your bones. Your skeleton may feel like a permanent structure, solid, stable, and unmoving, but in reality, it is anything but static. Every moment, specialized cells called osteoclasts are diligently breaking down old bone tissue, while other cells called osteoblasts are rebuilding it. This process, known as bone remodeling, occurs quietly and invisibly throughout your entire skeleton. Bones are constantly being reshaped based on how you move, what you eat, and even how you sleep. Roughly every 10 years, your entire skeleton is replaced, cell by cell. Bones adapt to stress, strengthening where needed and dissolving where they are not. Even in stillness, you are being reshaped, a silent evolution sculpted from within. And what about your liver? This remarkable organ can regrow itself from just 25% of its tissue. The liver is the only internal organ in the human body capable of regenerating itself to its full size even after significant injury or surgical removal. If just 1/4 of the liver remains, it can regrow into a fully functioning organ. This remarkable regenerative ability has been recognized since ancient times, even appearing in Greek mythology, where Prometheus's liver was eaten and restored daily. In real life, the liver's resilience is both astonishing and essential. It performs over 500 distinct functions, from filtering blood to metabolizing nutrients, detoxifying harmful chemicals, and producing essential proteins. To perform all of these vital tasks, it must remain whole. So, when damaged, the liver responds not with scarring, but with growth, rebuilding itself one cell at a time. Prepare to be amazed. You have more bacteria in your gut than human cells in your body. Inside your digestive system, there are trillions of tiny life forms, more numerous than all the human cells that make up your body. This microbial population, known as your gut microbiome, includes bacteria, fungi, and viruses that live symbiotically within you. These microbes help digest food, regulate your immune responses, produce essential vitamins, and even influence your mood and brain chemistry. Some scientists even refer to the microbiome as an invisible organ because it behaves like one, vital, integrated, and incredibly complex. At birth, your gut is almost sterile, but within days it becomes home to a flourishing ecosystem unique to you. You are not a single organism, but a colony, human and microbial, interwoven at the most intimate level, co-evolving in quiet cooperation. Your brain, that silent command center within your skull, produces enough electricity to power a small light bulb. At any given moment, the neurons in your brain are firing tiny electrochemical signals at incredible speed, generating enough electricity to illuminate a low-wattage light bulb. With over 100 billion neurons, each capable of forming thousands of connections, your brain is a living circuit board, constantly active even when you're asleep. These pulses of energy are responsible for everything from language and memory to breathing and blinking, yet we rarely feel this electrical activity. It hums quietly behind thought, emotion, and awareness. You are, in a very real sense, lit from within, not metaphorically but electrically, a softly glowing engine of thought. And it's made so your finger this on average within the through combinations of just 3 primary types of cones, red, green, and blue sensitive. Your brain can differentiate more than 10 million distinct hues. You can see subtle gradients in a sunset, pick out slight differences in shades of green, or distinguish between 2 nearly identical blues. This fine-tuned sensitivity evolved for survival, but it also gives rise to art, design, and beauty. In darkness, your eyes rest, but in daylight, they are one of nature's most refined instruments, decoding color with silent precision. And here's an amazing fact about your eyes. The cornea has no blood supply. It gets oxygen from the air. Unlike most tissues in your body, the cornea, the transparent outer layer of the eye, has no blood vessels. This is what keeps it crystal clear for optimal vision. But it still needs oxygen to survive. So how does it get it? The cornea absorbs oxygen directly from the air. Every time you blink, a thin film of tears spreads across the surface, capturing oxygen from the environment and delivering it to the cornea. It also receives nutrients from the fluid inside the eye. This system is delicate. When you sleep with your eyes closed, oxygen intake drops. That's why extended contact lens use can lead to discomfort. It interrupts the cornea's quiet breath of air. The human heart, though small, is incredibly powerful. Your heart creates enough pressure to squirt blood 30 feet. The human heart is not large, roughly the size of a clenched fist, but its strength is staggering. With each beat, it generates enough pressure to move blood throughout your entire body. In fact, if the aorta were opened, the heart's pressure is strong enough to squirt blood over 30 feet. Does this over 100,000 times a day without rest, from the moment you are in the womb until your final breath. This pressure comes from the coordinated contraction of cardiac muscle, forcing blood through valves and arteries in rhythmic pulses. It powers life silently, invisibly, a muscular metronome beneath your ribs, pulsing with quiet certainty, driving blood through the highways of your body. You might be surprised to learn that you grow taller in the morning than in the evening. When you wake up in the morning, you're slightly taller than you were the night before, often by as much as half an inch. This isn't magic, but physics. During the day, the cartilage between your bones, especially in your spine and knees, compresses under the weight of your own body. As you walk, stand, and sit, gravity gradually pushes the fluid out of these cushions. At night, when you lie down, the pressure eases and the cartilage reabsorbs fluid, expanding again. It's a daily rhythm of compression and release, a quiet dance between gravity and biology that subtly reshapes your body from sunrise to sunset and back again as you rest. Sleep may seem like a period of inactivity, but inside your brain, the opposite is true. Your brain is sometimes more active while you sleep than when you're wide awake. Sleep may feel like stillness, but inside your skull, activity can surge to remarkable levels, especially during rapid eye movement, REM sleep, the stage when most vivid dreaming occurs. During REM sleep, your brain lights up with bursts of activity. In some regions, it becomes even more active than during waking hours. Neural networks involved in memory consolidation, emotional regulation, and imagination become intensely engaged, replaying and processing fragments of your day. This may be when your brain integrates learning, reinforces habits, or solves problems silently. Far from being turned off, your sleeping brain is busy filing memories, rehearsing possibilities, and exploring inner landscapes. As your body lies quiet beneath the covers, your brain is hard at work. Remember what we discussed earlier about your bones constantly rebuilding themselves? You replace your entire skeleton every 10 years. Your bones may feel permanent, like carved stone, but in truth, your skeleton is constantly being dismantled and rebuilt. Every cell of your bones is gradually replaced by new material through a process called remodeling. Old bone tissue is broken down and reabsorbed, while new bone forms in its place. Over the span of a decade, your entire skeleton is renewed. This cycle responds to your lifestyle, adapting to physical stress, hormone levels, and nutrition. Weight-bearing exercise stimulates new growth, while inactivity leads to loss. Your body is not simply maintaining its framework, it's engineering it in real time, making your skeleton a living structure, tuned continuously to how you move through the world. Prepare for another astonishing revelation. Your body glows faintly in the dark, but the light is too dim for our eyes to detect. You are glowing always, though you cannot see it. The human body emits a faint bioluminescent light as a byproduct of metabolic reactions. These photons are released when high-energy molecules interact with oxygen, producing tiny flashes of light. This glow is about 1,000 times weaker than what the human eye can perceive, so we remain unaware of it. But with sensitive instruments, scientists have captured images of this soft emission. Strangely, the intensity varies with time of day, peaking in the late afternoon. The light follows the rhythms of your metabolism as if your body were broadcasting its inner fire. You are not merely warm and alive, you are quietly luminous. Your nervous system is incredibly fast. Nerve impulses travel faster than a Formula One car. Your nervous system is built for speed. When a signal travels from your brain to a limb to move a finger, pull away from heat, or speak, it races along neurons at incredible velocity. Some nerve impulses travel at speeds over 250 miles per hour, far faster than a Formula One car. This rapid communication is made possible by a biological structure called the myelin sheath, which insulates nerves and allows electrical signals to jump in a process called saltatory conduction. It's this blazing fast transmission that lets you react almost instantly to a threat or catch a falling glass before it hits the ground. Beneath your skin, a lightning network is always firing. Your sense of smell is far more powerful than you might think. Your sense of smell can detect 1 trillion different scents. The human nose is far more sensitive than once believed. For many years, it was thought that we could distinguish around 10,000 scents, but newer research suggests the number may be closer to 1 trillion. Inside your nose, around 400 different types of olfactory receptors line the nasal cavity, each tuned to detect specific chemical compounds in the air. These receptors send signals to the brain in unique combinations, forming a vast language of scent. You can distinguish the freshness of rain, the memory of a loved one's perfume, or the chemical warning of smoke, often without conscious effort. Your nose is not just a passive organ, it's a vast, invisible library constantly reading the world. Earlier, we talked about the body glowing. Humans are bioluminescent, but it's invisible to the naked eye. Like deep-sea creatures and glowing plankton, humans emit faint bioluminescent light. This glow doesn't come from exotic adaptations, but from ordinary metabolism. As your cells process energy, reactive oxygen molecules interact with lipids and proteins, producing small bursts of photons. Sensitive cameras have captured this faint light, not infrared heat, but visible photons radiating from your face, chest, and hands. Interestingly, the intensity of this glow follows your circadian rhythm, peaking in the late afternoon and fading overnight. While your eyes can't detect it unaided, your body glows softly in the dark, not with mystery or myth, but with the quiet chemistry of life. You are quite literally radiant, a gentle candle burning from within. As you age, your bones continue to change. Your bones stop growing in length, but not in width. During childhood and adolescence, your bones grow rapidly in length, stretching as growth plates expand. But by your late teens or early 20s, those plates close and your height stabilizes. That doesn't mean your skeleton is finished changing. While length remains constant, bones can continue to thicken throughout life, especially in response to stress or repetitive motion. If you take up weightlifting or endure years of physical labor, your bones respond by becoming denser and broader. Even the shape of your jaw, pelvis, and rib cage can shift with age. Your bones are not frozen in time. They're reactive, dynamic, and responsive to how you live, quietly reshaping themselves long after you stop getting taller. Here's an incredible testament to the body's resilience. You can survive without a large portion of your internal organs. Might seem that every organ in your body is essential, and many are, but the human body is surprisingly resilient. You can live without a spleen, one kidney, one lung, your gallbladder, your appendix, your stomach, your colon, or even much of your liver and small intestine. In some cases, these organs can be surgically removed due to injury or illness, and the remaining systems adapt. The liver can regenerate, and the remaining kidney compensates. The body reroutes, functions, and heals. This adaptability is extraordinary, a reflection of millions of years of evolutionary backup plans. Though each organ has a purpose, the body's ability to persist, even when incomplete, is one of its most remarkable traits. Inside your abdomen lies a long and winding path. Your intestines are over 20 feet long. Coiled inside your abdomen, folded and packed with geometric precision, your intestines stretch more than 20 feet in total length. The small intestine alone accounts for about 15 to 20 feet, responsible for absorbing nutrients from food. The large intestine, or colon, adds several more feet, reclaiming water and compacting waste. All of this tubing fits neatly inside your torso through tight folds and muscular contractions. If laid out straight, it would stretch across a small room. Despite its length, food moves through this winding path in a matter of hours, a journey of digestion, transformation, and absorption. You carry this complex pipeline with you always, silent and unspooling, feeding the rest of your body. The acid in your stomach is incredibly potent. The acid in your stomach can dissolve razor blades. Inside your stomach is a fluid more powerful than you might expect. Gastric acid, primarily composed of hydrochloric acid, has a pH of around 1. Strong enough to corrode metal. Laboratory tests, it can even dissolve thin steel razor blades given enough time. This strength is necessary to break down proteins and kill harmful microbes in your food. Yet your stomach doesn't digest itself. A protective mucus layer lines its walls, constantly renewing to keep the tissue safe from the very acid it produces. Every meal you eat triggers this biochemical storm, a carefully controlled burst of chemical fire, burning food down to its building blocks so life can continue. Another unsung hero of your body, you produce about a liter of mucus per day. Though it rarely gets the spotlight, mucus is one of your body's most versatile and essential substances. Every day, your respiratory and digestive systems produce nearly a liter of it, enough to fill a small bottle. It lines your nose, throat, lungs, and gut, trapping dust, bacteria, and allergens before they reach deeper tissues. Mucus keeps your airways moist, helps move food through your intestines, and even contains enzymes and antibodies to fight infection. Most of the time, you swallow it without noticing. It's not glamorous, but it's critical. This slippery, unseen barrier works constantly to protect you, coat you, and carry the microscopic debris of life away in silence, an action you do without even thinking. You blink around 20 times per minute, more than 10 million times per year. Without even thinking about it, you blink approximately 20 times every minute. Each blink takes only a fraction of a second, but over the course of a year, that adds up to more than 10 million separate closures of your eyelids. These tiny movements aren't just for moisture or protection. They also help rest the visual system, refresh the tear film, and protect the eyes from dust or sudden changes in light. Remarkably, your brain edits out the darkness during each blink, creating a continuous sense of vision even though your eyes are briefly shut. In this way, blinking is both biological and neurological, a rhythm that maintains the clarity of sight without ever interrupting your view of the world. Even when you're relaxed, your muscles are working. Your muscles are always slightly contracted. Even when you're relaxed, even when you lie completely still, your muscles are never entirely at rest. They maintain a subtle state of tension known as muscle tone. This baseline contraction is controlled by the nervous system and allows your body to remain upright, balanced, and ready to move. Without it, you would slump or collapse, unable to maintain posture. This constant readiness uses very little energy but provides immense stability. Even as you sleep, muscle tone persists just enough to keep your limbs aligned and your breathing steady. It's only during certain stages of deep sleep that some muscles fully relax. At all other times, your body is quietly holding itself together, a gentle hum of readiness beneath your skin. Heart is a tireless engine. The human heart beats around 100,000 times per day. Your heart is a tireless engine. Each day it contracts around 100,000 times, circulating blood through more than 60,000 miles of vessels. That means over 35 million beats per year and more than 5 billion over an average lifetime. It never pauses. From your earliest moments in the womb to your final breath, your heart works ceaselessly, squeezing, filling, releasing, all without conscious effort. It adjusts moment by moment to your posture, your breathing, your emotions, slows when you sleep, quickens when you move, and flutters when you feel. Even in silence, even in stillness, your heart is the pulse of your existence, a steady, lifelong percussion beneath the music of your body. Just like fingerprints, everyone has unique tongue prints. No two tongues are exactly alike. Just like your fingerprints, the surface of your tongue bears a distinct pattern of ridges, textures, and muscle shapes that are unique to you. While not commonly used for identification, tongue prints are so specific that biometric researchers have explored their potential for secure recognition systems. Your tongue's appearance is shaped by genetics, development, and daily habits. From how you speak and chew to how you taste and swallow, it is an organ of precision, strength, and sensitivity, with fine control that allows you to speak clearly, eat safely, and sense flavor in exquisite detail. Quietly, it carries your personal signature, one that, like your fingerprint, is entirely your own. And finally, a truly mind-blowing fact: your body is made of stardust. Literally, every atom in your body heavier than hydrogen was forged in the heart of a star. Carbon, oxygen, calcium, iron, the very elements that make up your cells, bones, and blood, were created in ancient stellar furnaces through nuclear fusion. When massive stars exploded in supernovas billions of years ago, they scattered these elements into space, seeding the raw materials of planets, oceans, and eventually life. The atoms that now form your body once drifted in the cold emptiness between stars before finding their way into Earth's crust, then into food, then into you. You are not just made of matter, you are made of history, time, and the long memory of stars. To put it all in perspective, remember this: there are more connections in your brain than stars in the Milky Way. Your brain, a universe contained within your skull, boasts around 86 billion neurons, each a tiny star capable of forging thousands of connections. These connections, the synaptic bridges across which thoughts and sensations leap, number over 100 trillion. A staggering figure exceeding even the estimated number of stars twinkling in the vast expanse of the Milky Way galaxy. These connections are the very bedrock of everything you are: memory, perception, movement, emotion, all woven together in an intricate tapestry of neural pathways. This isn't a static map etched in stone. Your brain is a living, breathing cartography in perpetual motion, constantly adapting, learning, rewiring itself in response to the torrent of experiences that flood your senses. With each passing thought, each cherished memory, a tiny electrical pulse surges through this cosmic web, a neuron flickering to life like a distant star igniting in the void. Consider this. Your brain can conjure hallucinations with no prompting from the outside world. Even in the suffocating silence and impenetrable darkness, your brain has the power to birth vivid sensory experiences, sights, sounds, even entire scenes unfolding within the theater of your mind, independent of any external stimulus. We call these hallucinations, and they arise when neural circuits normally triggered by sensory input spontaneously begin to fire. This can occur during the hallucinatory landscape of dreams in moments of profound sensory deprivation or as a consequence of underlying neurological conditions. What's truly remarkable is the sheer verisimilitude of these illusions. The very same regions of the brain that process real-world perception are actively engaged during hallucinations, blurring the lines between reality and fabrication. In essence, the brain is a simulator of unparalleled power, capable of constructing entire realities from within, even without the raw materials of light, sound, or touch. It is both a receiver, attuned to the symphony of the universe, and a projector capable of painting its own worlds onto the canvas of your consciousness. Ever wonder about goosebumps? Those tiny bumps that prickle your skin when you're cold or emotionally moved? They're a vestige of our more hirsute past, a leftover trait from a time when humans were covered in a thick coat of body hair. When you experience a chill or a surge of emotion, tiny muscles called erector pili muscles at the base of each hair follicle contract. This contraction causes your skin to dimple, creating the goosebump effect and the hairs to stand erect. This reaction, known as piloerection, once served a critical purpose for our hairier ancestors. Fluffed up the body's fur, creating an insulating layer that trapped more warmth or made them appear larger and more intimidating in moments of fear or confrontation. Today, with our comparatively sparse body hair, the effect is largely vestigial, a physiological echo of evolution's distant past. But the underlying mechanism remains, triggered not only by cold but also by strong emotions, awe, or even the stirring power of music. Goosebumps are a tangible connection to our evolutionary history, a physiological shiver that whispers of ancient instincts still hardwired into our nervous system after millions of years. Inside each of your cells, a drama unfolds millions of times a day. Your DNA unravels and rewraps itself in an intricate dance of genetic expression. Within the nucleus of every cell resides a complete set of your genetic instructions, encoded in strands of DNA nearly 2 meters in length. To fit within the microscopic confines of the nucleus, this genetic material is meticulously wound and packaged into structures called chromosomes, resembling tiny, tightly coiled spools. But DNA is not a static archive. Throughout the day, it undergoes a constant cycle of unwinding and rewinding, allowing specific genes to be accessed, read, copied, or repaired. In a single cell, this dynamic dance happens thousands of times, and across your entire body, with its trillions of cells, the total number of uncoilings reaches into the billions daily. Specialized enzymes act as molecular librarians, unzipping the double helix like a book being opened, allowing access to the genetic information within. Your bones, seemingly solid and unchanging, are in fact dynamic, living tissues, constantly replacing old calcium with new. While bone may appear to be a dry, lifeless material, it is far from inert. It is bone is every time on average saliva it even though while it this is the pain it is your gut scientist it produce your sense hidden as you this it works when the but when here's us although this seemingly insignificant shift helps regulate airflow, humidify incoming air, and optimize olfactory sensitivity. Some odor molecules are better detected with a slower stream of air, while others require more rapid intake. Your brain coordinates this quiet rhythm without your conscious awareness, ensuring that you are always breathing efficiently and effectively. Even as you sleep, your nostrils take turns, a soft relay of breath, optimizing function in the background of every moment. The tiny hairs inside your ear play a crucial role in detecting the direction of sound. Deep within your cochlea, the spiral-shaped organ of the inner ear, lie thousands of microscopic hair cells. These aren't hairs like those on your skin, but rather delicate, flexible structures that respond to vibrations in the fluid surrounding them. Each hair cell is tuned to a specific frequency, like a key on a piano, allowing you to distinguish between different pitches and tones. When sound enters your ear, it travels as pressure waves that move the fluid within the cochlea and bend the hair cells. This mechanical bending is converted into electrical signals, which the brain interprets as sound. But the brain also utilizes subtle timing and intensity differences between the signals received by each ear to determine the direction from which a sound is coming. Your ability to sense the direction of sound is not just about hearing, it's about spatial computation, a sophisticated process that allows you to navigate the auditory world around you. Imagine hearing the movement of your own eyeballs. In a rare auditory condition known as superior canal dehiscence syndrome, SCDS, a tiny hole in one of the bony canals of the inner ear causes sound to be conducted differently. People with this condition can hear a variety of internal sounds, including their own heartbeat, footsteps, chewing, and even the subtle mechanical sound of their own eyes moving in their sockets. This unusual phenomenon occurs because the gap in the bone creates an abnormal connection between the brain's motion sensing and sound sensing pathways, allowing internal vibrations to be amplified and perceived as sound. While this can be disorienting and uncomfortable, it reveals just how finely tuned and sensitive the inner ear truly is, constantly processing a symphony of internal vibrations that are usually filtered out by the brain. We are constantly surrounded by internal sounds, but in most people, the brain gently filters them away, allowing us to focus on the external world. The human ear is capable of detecting sounds across an extraordinary range of frequencies, from the low rumble of 20 Hz to the piercing shriek of 20,000 Hz. The lowest sounds you can detect, around 20 Hz, feel more like vibrations than distinct tones, a deep, almost palpable sensation that resonates through your body. The highest sounds, near 20,000 Hz, are piercing and sharp, often just at the edge of perception, a faint, high-pitched shimmer that can be difficult to hear, especially with age. This wide spectrum allows you to appreciate the deep resonance of a cello, the delicate trill of a flute, and the high shimmer of birdsong. With age, the upper limit of hearing tends to decline, especially for high-pitched sounds, a natural consequence of the aging process. Even within your lifetime, your hearing range spans nearly 10 musical octaves, far more than most animals, allowing you to experience the richness and complexity of the auditory world. The ear translates pressure waves in the air into neural signals with exquisite speed and precision, a mechanical marvel and an acoustic window to the world. Your eyes, often perceived as unchanging, are actually never the same size throughout your life. Though it's commonly believed that eye size remains constant after childhood, your eyes actually grow and change subtly over time. At birth, an infant's eyes are roughly two-thirds the size of an adult's eyes. They continue to grow gradually throughout childhood, reaching near-adult dimensions in the teenage years. But even in adulthood, subtle changes continue to occur. The lens, responsible for focusing light onto the retina, thickens with age, affecting its ability to change shape and focus on objects at different distances. The muscles around the iris, which control the size of the pupil, may weaken over time, affecting the pupil's ability to constrict and dilate in response to changes in light levels. Additionally, the shape of the eyeball itself can shift slightly, which is why many people develop farsightedness, presbyopia, as they get older, requiring reading glasses to see objects up close. These small changes alter how light is focused and can affect vision over time. The eye may appear unchanging on the surface, but it evolves quietly, adapting to the long arc of a lifetime, adjusting its lens with each passing year. While your bones generally stop developing in your late 20s, your face continues to change throughout your life, a testament to the dynamic nature of the human body. By your late 20s, most of your skeletal growth is complete. Growth plates, the areas of cartilage at the ends of long bones responsible for growth, close, long bones reach their final length, and your overall height stabilizes. However, certain parts of your body continue to shift and remodel, particularly your face. The bones of the skull undergo subtle remodeling, changing in shape and density over time. The jaw may change shape, becoming more or less prominent. The nose can become more prominent due to changes in the cartilage and soft tissues. The eye sockets may deepen, creating a more pronounced appearance. At the same time, the soft tissues of the face, including fat pads, muscles, and skin, gradually shift and lose volume, altering the contours of your appearance. These changes are slow and subtle but constant, reflecting the passage of time not just through aging skin but through the quiet reshaping of the bone beneath. The liver, a remarkable organ, performs over 500 separate functions, essential for maintaining life and health. Your liver, one of the most versatile and vital organs in your body, weighing about 3 pounds and located just under your ribs on the right side of your abdomen, performs over 500 distinct biochemical tasks, making it a true workhorse of the body. It filters toxins from the blood, removing harmful substances and waste products. It produces bile, a fluid essential for digestion, breaking down fats and aiding in the absorption of nutrients. It breaks down medications, metabolizing drugs and preparing them for elimination from the body. It stores glycogen, a form of glucose, providing a readily available source of energy. It regulates blood clotting, producing proteins that are essential for forming blood clots and preventing excessive bleeding. It metabolizes fats and proteins, breaking them down into usable components. It helps balance hormones, regulating the levels of various hormones in the bloodstream. It also plays a key role in immune defense, producing immune factors and helping to fight off infections. It detoxifies harmful substances you ingest or absorb, protecting the body from the damaging effects of toxins. Unlike many other organs that focus on a limited number of tasks, the liver works on dozens of processes simultaneously, like a central control center humming with silent activity. It is tireless, adaptable, and uniquely regenerative, capable of repairing itself after injury. Without it, life is impossible. With it, complexity becomes manageable and chemistry becomes seamless. Red blood cells, the oxygen carriers of the body, have a unique characteristic. They carry oxygen but have no nucleus. Unlike most cells in your body, mature red blood cells, also known as erythrocytes, lack a nucleus, the central control center that houses the cell's DNA. This absence of a nucleus makes room for hemoglobin, the iron-rich protein that binds to oxygen and transports it throughout the body. As a result, red blood cells can carry far more oxygen than if they had retained a nucleus. They begin life with a nucleus, but lose it during development in the bone marrow, the spongy tissue inside bones where blood cells are produced. This enucleation process gives red blood cells their distinctive biconcave shape, which maximizes surface area for oxygen exchange and increases their flexibility, allowing them to squeeze through capillaries thinner than a human hair. But their nucleus-free design comes at a cost. Red blood cells can't divide or repair themselves. After about 120 days, they become worn out and are removed from circulation and replaced with new red blood cells. Each cell is short-lived but essential, a single-use courier of breath delivering life-giving oxygen to every corner of your body. Your body contains enough fat to make approximately 7 bars of soap, an intriguing comparison that highlights the chemical properties of fat. Fat, also known as adipose tissue, plays many essential roles in the human body, serving as a primary source of energy storage, providing insulation to maintain body temperature, regulating hormone production, and even protecting vital organs from injury. But if rendered down and processed, the average adult carries enough body fat to create roughly 7 full-size bars of soap, a surprising fact that underscores the chemical composition of fat. This unusual comparison stems from the historical process of soap making, which traditionally involved combining animal fat with lye, a highly alkaline substance. The lye reacts with the fat in a process called saponification, creating soap. Of course, your body fat is much more than just a raw material for soap making. It's a metabolically active tissue, constantly releasing hormones, responding to stress, and communicating with other systems in the body. Its distribution and function vary depending on factors such as sex, genetics, and lifestyle. Though often misunderstood or maligned, fat is an essential component of a healthy body. Without it, the body cannot function properly, and life becomes fragile instead of resilient. A single human hair, seemingly delicate, can hold about 100 grams of weight, a testament to its surprising strength. Though hair may appear fragile and delicate, each individual strand is surprisingly strong, capable of withstanding a significant amount of force. Single human hair can support up to 100 grams of weight without breaking, roughly the weight of a small apple, defying expectations given its slender appearance. This strength stems from its complex structure, a dense arrangement of keratin proteins tightly coiled and bonded together in layers. These proteins form long interlocking chains, creating a strong and resilient fiber. When combined across the entire scalp, the hundreds of thousands of hairs on a human head can collectively support the weight of an adult person, a remarkable feat of engineering. Beyond strength, hair is also remarkably elastic, able to stretch up to 30% of its length when wet and return to its original shape without damage, a property that contributes to its overall durability. So while each strand may seem fragile, together they form one of nature's most efficient fiber systems, light, resilient, and quietly powerful. The sartorius muscle, the longest muscle in your body, runs from your hip to your knee, playing a key role in leg movement and flexibility. Running diagonally across the thigh, the sartorius muscle is the longest muscle in the human body, a slender, ribbon-like muscle that contributes to a variety of movements, stretches from the outer edge of your hip, curves across the thigh, and ends near the inside of your knee, a long and winding path that reflects its multifaceted function. This slender muscle assists in a range of movements, flexing the hip, bending the knee, and allowing the leg to rotate outward. It's the muscle that enables you to cross your legs gracefully or pivot your foot to the side with precision. Though not especially large or powerful compared to other leg muscles, the sartorius plays a subtle and graceful role in everyday motions, contributing to balance, coordination, and flexibility. Its length and positioning are a quiet reminder of the body's architectural elegance, long lines engineered for motion, balance, and subtle control. You use over 30 muscles just to smile, a complex coordination that reflects the emotional depth and nuance of this universal expression. A smile may seem like a simple gesture, but it's actually powered by a small orchestra of muscles, working together in a precise and coordinated manner. More than 30 individual muscles coordinate to lift the corners of your mouth, crease the skin around your eyes, raise your cheeks, and adjust your jaw, creating the characteristic appearance of a smile. Even the slightest variation in a smile can involve different muscle groups, reflecting a wide range of emotions, from genuine joy to subtle amusement to ironic detachment. Some of these muscles work voluntarily under conscious control, while others are involuntary, activated automatically when you experience genuine happiness. The brain's emotional centers are wired directly to these facial muscles, which is why real smiles, known as Duchenne smiles, are hard to fake, involving the muscles around the eyes as well as the mouth. Every smile is a delicate performance, mechanical, emotional, and deeply human, a reflection of our inner state expressed through the intricate movements of our facial muscles. Some of your blood vessels are so small that red blood cells must squeeze through one at a time, highlighting the microscopic scale of nutrient exchange in the body. Your circulatory system is a vast network stretching over 60,000 miles throughout your body, delivering oxygen and nutrients to every cell and removing waste products. But some of its most important passages are also the tiniest, capillaries, the smallest of blood vessels. These microscopic vessels are so narrow that red blood cells must pass through in single file, often bending and squeezing to fit through their narrow lumens. Capillaries connect arteries and veins, forming a bridge between the incoming flow of oxygenated blood and the outgoing flow of deoxygenated blood. They are the sites where oxygen and nutrients pass from the blood into the surrounding tissues and where waste products are carried away, a vital exchange that sustains life at the cellular level. Capillary walls are just one cell thick, enabling easy diffusion of gases and nutrients across the membrane. At this microscopic scale, blood doesn't flow in broad streams but trickles precisely, slowly, and intimately, allowing for maximum contact between red blood cells and the surrounding tissues. Life is sustained not just by the great pulses of the heart, but by these silent single-file exchanges deep within your tissues. While the brain has no pain receptors, the surrounding tissue does, explaining why headaches and head injuries can be so excruciating. The human brain, the control center for all sensation, processes pain signals originating from throughout the body, but it cannot feel pain itself. The neurons that compose your brain lack nociceptors, the specialized receptors that detect tissue injury and transmit pain signals to the brain. That's why neurosurgeons can operate on the brain while the patient is awake without causing direct pain to the brain tissue. However, the tissues surrounding the brain, including the meninges, the membranes that protect the brain and spinal cord, scalp, blood vessels, and nerves, are richly innervated with pain receptors, That's why headaches, trauma, or swelling in the skull can be excruciating, triggering pain signals from these surrounding structures. The pain associated with brain injuries or conditions often arises from these sensitive tissues rather than from the brain tissue itself. The paradox is striking. The organ responsible for all feeling is itself insensate, a central switchboard that cannot register injury within its own walls. There are approximately 37 trillion cells in the human body, a vast and diverse community working together to sustain life. The human body is a mosaic of living cells, estimated to number around 37 trillion in total, a staggering quantity that underscores the complexity of human biology. These cells come in over 200 distinct types, each specialized for a different role, reflecting the division of labor required to maintain a complex organism. Skin cells form protective barriers, shielding the body from the external environment. Neurons transmit electrical signals, enabling communication throughout the nervous system. Blood cells carry oxygen and fight infection, essential for maintaining the body's internal equilibrium. Each cell contains the full human genome, a complete blueprint of life, but activates only the genes it needs to perform its specific function, a process called gene expression. Cells live, work, and die in patterns measured in hours or days, continually renewing tissues and maintaining life. They operate like a self-organizing society, forming muscles, bones, organs, and even thought itself. Every moment, countless cells coordinate their activities to keep you alive, an invisible population working in unity beneath the surface of your skin. Every cell contains approximately 2 meters of DNA, a remarkable feat of packaging that allows a vast amount of genetic information to fit within a tiny space. Inside the nucleus of almost every human cell lies a tightly packed strand of DNA measuring around 2 meters in length if fully uncoiled, a testament to the incredible density of genetic information. This double helix carries your complete set of genetic instructions, folded with extraordinary precision to fit into a space just 6 microns wide, a microscopic realm. The DNA wraps around proteins called histones, forming coils within coils, like thread on a microscopic spool, creating a hierarchical structure that condenses the DNA and protects it from damage. If you could string together the DNA from all your cells, it would stretch to the sun and back hundreds of times, a mind-boggling distance that emphasizes the sheer quantity of genetic information contained within your body. Yet inside your cells, it stays hidden, quietly orchestrating the production of proteins, guiding development, and recording the molecular memory of life. Your genetic code is not just long, it is deeply, intricately organized, a masterpiece of molecular engineering. Your bones contain living tissue and stem cells, a vibrant and dynamic environment that belies their seemingly inert appearance. Though often imagined as lifeless scaffolding, bones are vibrant, living organs, constantly being remodeled and renewed through a complex interplay of cellular activity. Within their hard outer structure lies a soft, spongy interior filled with bone marrow, a rich and dynamic tissue where blood cells are born. This marrow houses hematopoietic stem cells, capable of differentiating into red blood cells, white blood cells, or platelets, essential components of the blood that carry oxygen, fight infection, and promote clotting. Bones are also home to osteoblasts and osteoclasts, cells that constantly rebuild and reshape the skeletal framework, ensuring its strength and integrity. Blood vessels thread through bone, nourishing it from within and providing a lifeline for the resident cells. Even the compact outer layers of bone are alive, responding to stress, injury, and hormone levels, adapting to the changing demands of the body. Your bones are not static or dead. They are animated, responsive structures, quietly pulsing with life from the inside out. Gut bacteria outnumber your human cells and weigh about 3 pounds, highlighting the intimate relationship between humans and microbes. Inside your digestive tract lives an entire ecosystem, a bustling community of trillions of microbes that collectively outnumber your own human cells, a surprising fact that underscores the importance of the gut microbiome. This complex community, known as the gut microbiome, includes bacteria, viruses, fungi, and other microorganisms that play a vital role in human health. These microbes help digest food, breaking down complex carbohydrates and fibers that the human body cannot digest on its own. They produce essential vitamins, such as vitamin K and certain B vitamins that are crucial for various bodily functions. They regulate inflammation, helping to maintain a balanced immune response and prevent chronic diseases. They influence mental health, affecting mood, behavior, and cognitive function through the gut-brain axis. Altogether, these microbes weigh around 3 pounds, roughly the weight of your brain, a remarkable mass of microbial life residing within your digestive system. Your microbiome is shaped by your diet, environment, birth method, and even the way you were fed as a baby, making it unique to you like a microbial fingerprint. Recent more than the rest, some can you generate each day. Some of the still most of this renewal happens without any conscious sensation, thought, or effort, a silent and continuous process that sustains life. Damaged cells are dismantled and recycled, their components reused to build new cells. Stem cells divide, differentiate, and migrate to where they're needed, replacing worn-out or damaged cells and maintaining tissue homeostasis. You are, in a very real sense, always being rebuilt, cell by cell, moment by moment. The body you fall asleep in tonight is not the exact body you woke up in this morning, a subtle but profound transformation that reflects the constant flux of life. You are not fixed in time. You are flowing cell by cell through the river of renewal. Muscles remember previous workouts for months, a phenomenon known as muscle memory that makes it easier to regain strength after periods of inactivity. Even after long periods without exercise, muscles retain a kind of cellular memory, a lasting adaptation that allows them to respond more quickly and efficiently when training is resumed. When you work out regularly, your muscle cells grow in size and strength, a process called hypertrophy. They also increase the number of nuclei they contain, the cellular structures that control protein synthesis. These extra nuclei persist even if the muscle shrinks from disuse, remaining as a kind of cellular archive of previous training. When you resume training, those nuclei help rebuild the muscle faster than before, allowing for a more rapid increase in size and strength compared to someone who has never trained. This is why people who were once fit often regain strength more quickly than beginners, a testament to the lasting effects of muscle memory. The memory isn't stored in the brain in the same way as a learned skill. It's embedded in the cells themselves, a structural adaptation that primes the muscle for future growth. Your muscles remember effort, they remember movement, they remember resilience, and given time, they remember how to return to strength. Hair and nails don't keep growing after death. It's an illusion caused by skin retraction, a common misconception that stems from the changes that occur in the body after death. There's a persistent myth that hair and nails continue growing after death, fueled by anecdotal observations and a misunderstanding of the biological processes involved. In reality, hair and nails do not grow after death because growth requires cell division, which ceases when life ends. The illusion of growth is caused by dehydration, a natural process that occurs after death as the body loses moisture. As the skin dehydrates, it retracts, pulling back from the hair follicles and nail beds, making the hair and nails appear longer. This is not true growth, but rather a change in the surrounding tissue that creates the false impression of continued growth. The hair and nails remain the same length. It's the surrounding skin that shrinks, revealing more of them. So while it may appear that hair and nails are growing after death, it's simply an optical illusion caused by the changes in the skin, a final deception played by the body after life has ceased. After death, the body undergoes a series of changes, and one of the most curious is the apparent lengthening of hair and nails. This isn't actual growth, it's an illusion created by dehydration. As the body loses moisture, the skin around the hair follicles and nail beds retracts slightly, revealing more of the underlying structure. Since hair and nail growth require active metabolism, and that ceases when the heart stops and cells begin to die, true growth is impossible. Still, the myth of post-mortem growth persists. The effect can look eerily lifelike, fueling speculation about the supernatural. But the truth is far more anatomical than mystical. The body isn't continuing to grow, it's simply changing shape in the stillness, guided by the silent physics of drying and decay. Imagine a desert landscape where the receding waters expose the contours of the earth, revealing details previously hidden. Similarly, the body after death reveals what was already there, concealed beneath the surface. White blood cells, the body's microscopic defenders, possess a built-in GPS to locate infections. When your body detects an infection or injury, these immune cells leap into action, rushing to the site of the problem. They don't just float aimlessly through the bloodstream, They navigate with precision, following chemical signals emitted by damaged tissues or invading microbes. This process, called chemotaxis, works like an internal GPS system, guiding the white blood cells to their target with remarkable accuracy. Molecules released at the site of infection form a gradient, a kind of chemical map that the white blood cells sense, moving towards the source. Once they arrive, they engulf bacteria, release enzymes to break them down, and summon reinforcements, creating a microscopic battlefield where the body fights for its health. All of this happens silently, invisibly, every hour of every day. Immune system isn't just reactive, it's intelligent, directional, and constantly scanning the map of your body for danger, like a vigilant security force patrolling a vital perimeter. You possess vestigial muscles that once helped your ancestors wiggle their ears. Embedded beneath your skin are tiny, almost forgotten muscles called auricular muscles. In many mammals, these muscles allow the ears to rotate, helping them to pinpoint the source of a sound with incredible accuracy. Think of a deer in the forest, its ears constantly swiveling to detect the slightest rustle in the undergrowth. Humans still have these muscles, and some people can even wiggle their ears using them. But for most of us, they lie dormant, unused relics from our evolutionary past when mobile ears offered a significant survival advantage. Over time, as other senses took precedence and head movement became more efficient, these muscles faded in function but not in form. Today, they're a quiet biological souvenir, a reminder of an ancient heritage that still whispers from the edges of our anatomy. They are a testament to the adaptive power of evolution, a physical echo of a time when survival depended on the ability to hear the faintest whisper of danger. Taste buds, the gatekeepers of flavor, are replaced every 10 to 14 days. Your ability to taste, to detect sweetness, bitterness, saltiness, and umami depends on tiny clusters of sensory cells called taste buds, most of which live on your tongue. But these cells are short-lived, constantly exposed to heat, food particles, and friction. They wear out quickly and are replaced every 10 to 14 days, ensuring that your sense of taste remains sharp and responsive. New taste receptor cells grow from basal cells at the base of each bud and gradually move upward, restoring your sense of flavor. This constant regeneration ensures that your sense of taste stays acute, even after a burn or illness. Consider that the foods you love today are being perceived by completely new cells from just weeks ago, a cycle of renewal that transforms eating into a living, dynamic experience. It's a reminder that our bodies are constantly in flux, renewing themselves in ways we often don't perceive. There are more nerve endings in your fingertips than almost anywhere else in your body. Your fingertips are among the most sensitive areas of your body, exquisitely designed for tactile exploration. Beneath the skin, thousands of specialized nerve endings lie densely packed, responding to pressure, texture, vibration, temperature, and pain. These nerves are so finely tuned that they can detect textures less than a micron thick or distinguish between surfaces by the feel of a single grain. This sensitivity is what allows you to read Braille, thread a needle with precision, or feel the faintest breeze on your skin. The brain devotes an unusually large portion of its sensory map to your fingers, giving them priority over much larger areas of the body. When you touch the world, your fingertips do more than sense. They perceive, interpret, and translate the physical into thought, transforming the simple act of touch into a complex cognitive process. The body has a backup system for controlling your heartbeat. Your heartbeat is regulated by a natural pacemaker, a cluster of cells in the right atrium called the sinoatrial node. These cells generate electrical impulses that trigger each beat, keeping your rhythm steady and consistent. But what happens if this primary system fails? The body has backup pacemakers. Other clusters of cells, like the atrioventricular node and specialized fibers deeper in the heart, can take over, though at a slower pace, but still effective in maintaining circulation. This built-in redundancy helps protect against sudden cardiac failure. The heart's rhythm isn't controlled by conscious will, but by a hierarchy of biological timing systems, all waiting silently in line, ready to step in if needed. Your heartbeat is not just automatic, it's protected by design, with contingencies prepared for silence. Your skin is the largest organ in your body, covering about 20 square feet in the average adult. Your skin is not just a protective layer, It's the body's largest organ, weighing around 8 pounds on average. It shields you from bacteria, regulates temperature, detects touch sensations, and even produces vitamin D in response to sunlight. This remarkable organ is your first line of defense against the outside world. The skin is composed of 3 layers: the outer epidermis, the supportive dermis, and the inner hypodermis. Within these layers live blood vessels, nerve endings, sweat glands, and hair follicles, all working together to maintain balance and protect your internal environment. Skin regenerates constantly, shedding and renewing itself approximately every month. Though often taken for granted, it is your thermal insulator, your primary interface with the outside world, and a testament to the body's incredible ability to adapt and protect. You lose up to a liter of water every day just from breathing and skin evaporation. Even when you're not sweating visibly, your body is constantly losing water through a process called insensible water loss. You exhale moisture with every breath, and tiny amounts evaporate through your skin even when it's dry and cool to the touch. Over the course of a day, this can add up to nearly a liter of water, and even more if the air is warm and dry or if you're physically active. You don't feel it leaving and you can't see it, but it's always happening. That's why staying hydrated is so important. Even when you're resting, your body is gently evaporating into the air, a silent exchange with your environment as natural as the rise and fall of your breath. Your body contains trace amounts of gold. Deep inside your bloodstream, there are minuscule amounts of gold, about 2 milligrams in total, scattered throughout your body. This elemental gold isn't decorative, but plays subtle biological roles, including participation in joint health and enzyme activity. Gold atoms are often bound within larger molecules or proteins and distributed in trace quantities along with other metals like zinc, copper, and iron. These elements originate in the earth, in food and water, and ultimately from ancient stellar explosions that seeded the solar system. So, while the gold inside you isn't enough to mine, it's a quiet reminder that your body is built from the dust of stars, precious, rare, and universal. Bones are hollow but incredibly strong. Many of your bones, especially those in the arms and legs, are not solid throughout. They're hollow in the center, filled with bone marrow, a soft, spongy tissue that produces blood cells. The structure might sound fragile, but it's actually a brilliant adaptation, optimizing both strength and lightness. Hollow bones are lighter, making movement more efficient, while their outer layer, compact bone, is incredibly dense and strong, able to withstand significant force. Inside, the trabecular or spongy bone adds resilience, distributing stress like the framework of a bridge. This combination of strength and lightness is so effective that engineers study it when designing buildings and aircraft. Your skeleton isn't just support, it's optimized architecture, shaped by nature over millions of years for strength, speed, and survival. Each of your kidneys contains around 1 million tiny filters. Your kidneys are relatively small, each roughly the size of a fist, but inside them are about 1 million microscopic filtration units called nephrons, each working tirelessly to cleanse your blood. Each nephron filters your blood, removing waste products, balancing electrolytes, and regulating water levels. Blood enters the kidneys through arteries, passes through these intricate filters, and exits cleansed, ready to circulate throughout the body. The filtered waste becomes urine, while essential substances are reabsorbed, ensuring that your body retains what it needs. Every day, your kidneys filter around 50 gallons of blood, refining it with extraordinary precision. Despite their size, these organs are among the most efficient processes in your body, working quietly to keep your internal environment in balance, minute by minute, drop by drop. The brain uses more energy than any other organ, up to 20%. Although the brain makes up only about 2% of your body weight, it consumes around 20% of your total energy supply, a disproportionately large amount. That energy powers neurons as they fire electrical signals, maintain cellular health, and manage the complex chemical exchanges that underlie thought, memory, and emotion. Even at rest, when you're not thinking intensely, your brain remains metabolically active, constantly humming with activity. It requires a constant supply of glucose and oxygen, delivered by an extensive network of blood vessels. If the brain's energy flow is interrupted even briefly, its functions falter. The mind may feel light, ethereal, or effortless, but behind every moment of awareness is a steady current of power feeding your inner fire. A fetus can heal wounds without leaving scars. During early development, the human body possesses a remarkable ability. It can heal wounds completely without forming scar tissue. In the womb, fetal skin has a different cellular composition and immune response compared to adult skin. When injured, it regenerates seamlessly, restoring tissue without fibrosis or permanent marks. This ability is lost after birth, likely due to changes in collagen production, inflammation, and immune system maturity. Scientists are studying fetal healing in hopes of understanding how to replicate it in adults to one day heal without scars. It's a glimpse of the body's hidden potential, not just to repair, but to restore perfectly and invisibly, as if the injury had never happened at all. Tears have different chemical compositions depending on why you cry. Not all tears are the same. Your body produces three main types, each with a distinct purpose and chemical makeup. Basal tears, which keep your eyes moist and lubricated. Reflex tears, which wash away irritants like dust or onion fumes. And emotional tears, which are triggered by feelings such as sadness, joy, or frustration. Emotional tears contain higher levels of stress hormones and natural painkillers, suggesting a biological link between crying and emotional regulation. These chemical signatures are unique to the kind of tear being shed. While tears may seem like simple water, they are complex, layered fluids that reflect both your biology and your inner state. In each drop is a story of function, of feeling, and of the body's quiet ways of release. The heart has its own electrical system. It can beat outside the body. Your heart doesn't need instructions from your brain to beat. It contains its own built-in electrical system centered around the sinoatrial node, which generates rhythmic impulses that control contraction. If removed from the body and supplied with oxygen and nutrients, the heart can continue beating for a time completely on its own, a testament to its inherent autonomy. This property, known as automaticity, is unique among muscles. It ensures that the heart continues to function even if nerve signals are disrupted. In emergency medicine, defibrillators work by resetting this internal rhythm, allowing the heart's natural pacemaker to regain control. Your heartbeat is not just muscle. It's signal, pulse, and independent rhythm echoing in time without ever needing to be told when to begin. The human embryo has a tail for a brief period. During early development, every human embryo grows a small tail, a structure that reflects our shared ancestry with other vertebrates. Around 4 to 5 weeks after fertilization, this tail extends beyond the rest of the developing body, containing multiple vertebrae. But as the embryo matures, the tail is gradually reabsorbed into the body, leaving behind the coccyx or tailbone, a vestigial remnant of our evolutionary past. In rare cases, children are born with small, tail-like extensions, a rare and usually harmless occurrence. Though hidden in adulthood, this early tail is a fleeting glimpse of deep biological history, an echo from a time when tails were not symbolic but essential for balance and locomotion. You can function with half a brain and sometimes better than before. In rare medical cases such as severe epilepsy, surgeons may remove or disconnect an entire hemisphere of the brain, a procedure called hemispherectomy. Remarkably, especially in young patients, the remaining half of the brain can adapt and take over many lost functions. Speech, movement, and memory can all recover to surprising degrees. This plasticity is most pronounced in children, but even adult brains show some capacity to rewire. The brain is not hardwired like a machine. It's fluid, flexible, and capable of extraordinary compensation. Half a brain may sound like a tragic limitation, but in some cases it becomes the path to healing, revealing just how adaptable human consciousness can be. People with synesthesia can taste sounds or see colors in music. For individuals with synesthesia, the senses are intertwined in remarkable and often unexpected ways. A sound might evoke a burst of color. A letter might feel sharp or soft to the touch. A musical note might carry the flavor of mint or cinnamon. This blending of sensory perception is involuntary and consistent. The same stimuli always produce the same cross-sensory experience. While the exact cause remains unclear, synesthesia appears to involve increased connectivity between brain regions. It's not a disorder, but a variation, a different way of interpreting the world. For those who experience it, life can be rich with unexpected textures, flavors, and colors. The mind becomes a prism, turning simple input into a spectrum of perception. Bone marrow is the source of all red blood cells. Deep inside your bones, particularly in the pelvis, ribs, and long bones, lies soft, spongy tissue known as bone marrow. This tissue is home to hematopoietic stem cells, the origin of all the red blood cells in your body. These stem cells divide and differentiate into mature cells that enter the bloodstream carrying oxygen to your tissues. Red blood cells are produced at an astonishing rate, millions every second, all from this hidden factory within your skeleton. Marrow also produces white blood cells and platelets, making it a cornerstone of both oxygen delivery and immune defense. Without bone marrow, blood could not be replenished, and life could not be sustained. The liver can detoxify almost any natural poison up to a point. Your liver is a master chemist, capable of neutralizing a vast array of toxins that enter your body. When you ingest something harmful, whether alcohol, plant toxins, or metabolic byproducts, your liver processes these substances using specialized enzymes, transforms fat-soluble compounds into water-soluble forms that can be excreted through urine or bile. This detoxification happens continuously, quietly protecting you from daily exposures to harmful substances. But the liver has limits. If overwhelmed by too many toxins too quickly, its enzymes become saturated and damage can occur. Still, its capacity is astonishing. Every day, your liver filters more than a liter of blood per minute, acting as both barrier and shield, a silent guardian of your internal chemistry. The human neuron, the brain, this ability, learning in the brain, your brain, imagine within these, or when you don't just your memory visual each time within these, unlike the mind in the ret, they detect, they help you lining sometimes. It's not while the liver, your body, though women may, human this engineer through eons of evolution, your body has innately adapted to these mechanical truths, refining bone alignment and muscle placement to maintain balance, upright posture, and resilience against the relentless push and pull of gravity. Consider the Achilles tendon, a marvel of biological engineering. Connecting your calf muscles to your heel bone, it's the thickest and strongest tendon in the human body, capable of handling forces exceeding 1,000 pounds. When you run, jump, or even climb stairs, it acts like a spring, storing and releasing energy, absorbing the impact of each step and propelling you forward with remarkable efficiency. Under peak strain, the Achilles tendon showcases its incredible resilience, withstanding forces that would tear lesser tissues. This strength is a testament to its dense collagen structure and the precise way it transmits muscular effort across the ankle joint. Yet, despite its inherent robustness, the Achilles tendon remains vulnerable to injury, particularly from overuse or sudden jarring stress. It's a perfect illustration of biological design, powerful, efficient, yet inherently susceptible to wear and tear. A cable of pure function diligently powering your every step, often without conscious acknowledgement. You possess a built-in reflex designed to prevent you from biting your own tongue, a safeguard that typically functions flawlessly until it doesn't. This intricate system incorporates protective reflexes that make it remarkably difficult to accidentally bite your tongue while chewing. Sensory feedback, transmitted swiftly from the tongue to the brain, precisely coordinates jaw movement, ensuring your teeth close at the correct moment and in the correct position. However, under specific conditions, such as during a seizure or when chewing too rapidly and carelessly, this reflex can falter, leading to painful accidental bites. This seemingly minor detail underscores the body's constant quiet vigilance, a symphony of systems working in concert to protect even the most vulnerable parts from harm. We rarely pause to consider it, but each meal represents a remarkable feat of coordination, precision, and split-second timing, all bolstered by built-in safeguards that generally go unnoticed. Dreams can serve as a canvas for encoding memories, solving complex problems, and even rehearsing our deepest fears. As you drift off to sleep, your brain transitions into a remarkable state of heightened internal activity, a far cry from simple stillness. During specific sleep stages, particularly REM sleep, your brain actively consolidates memories, processes emotions, and runs intricate simulations. Numerous studies have illuminated the power of dreams to strengthen learning, facilitate the resolution of seemingly intractable problems, and allow us to rehearse potential threats in a safe, imagined environment. The amygdala, the brain's emotional center associated with fear and intense feelings, remains highly active during dreaming. The hippocampus, crucial for memory formation, replays fragmented scenes from our waking lives. While the narratives of our dreams can often appear surreal and illogical, their underlying purpose is profoundly practical, organizing our experiences, optimizing our future behavior, and safeguarding our mental well-being. You are not merely idle while dreaming, you are actively rehearsing life itself within the quiet theater of sleep. You consciously perceive only a sliver of the vast sensory input your body continuously receives. At this very moment, your senses are bombarded with a torrent of information: the gentle pressure of your clothing against your skin, the ambient temperature of the air around you, the distant hum of background noises. Yet your conscious mind processes only a tiny fraction of this overwhelming influx. The remainder is meticulously filtered, ignored, or processed unconsciously. Brain prioritizes stimuli that are novel, urgent, or emotionally significant, creating a manageable stream of information for your awareness. This filtering mechanism is essential for preventing sensory overload. Without it, you would be perpetually overwhelmed, unable to focus or function effectively. Specialized neural pathways, including those within the thalamus and prefrontal cortex, act as gatekeepers, carefully directing attention to what truly matters. Beneath the surface of conscious awareness, your body continuously listens, evaluates, and responds to the surrounding environment. You are constantly surrounded by sensation, but your mind selectively crafts the narrative it chooses to tell. Remarkably, some of your cells are older than your very bones. While many cells within your body are in a perpetual state of renewal, skin cells, blood cells, and gut cells are replaced every few weeks. Others exhibit remarkable longevity. Certain neurons in your brain, for example, have been your constant companions since birth, remaining with you throughout your entire life. Muscle cells, too, can endure for decades, and even some fat cells persist for extended periods. Meanwhile, your skeleton, which feels so solid and unchanging, undergoes complete remodeling approximately every 10 years. This means that some of your oldest cells reside within your soft tissues, while your bones are, in a sense, younger than they appear. You are not uniformly aged. Your body is a fascinating mosaic of timelines, with some parts ancient and others newly formed, all seamlessly stitched together in the ever-flowing river of time. Human blood boasts a multitude of rare types, extending far beyond the familiar A, B, and O classifications. While most individuals are acquainted with the major blood groups and their Rh positive or negative status, the reality is far more complex. Beyond these common categories lie over 30 recognized blood group systems, each defined by unique antigens residing on the surface of red blood cells. Some of these blood types are exceedingly rare. The Bombay blood type, for instance, lacks a fundamental antigen present in nearly all other blood types, restricting transfusions to individuals with the same rare type. Others, such as the incredibly rare golden blood, Rh null, lack all Rh antigens and are found in fewer than 50 people worldwide. Your blood carries a far more intricate signature than most realize, a molecular identity shaped by genetics, evolution, and the unpredictable forces of biological chance. Your immune system retains memories of past infections for decades, providing long-lasting protection. Once your body successfully combats a virus or bacterium, it doesn't simply forget the encounter. Specialized immune cells, particularly memory B cells and memory T cells, persist long after the infection has subsided, diligently storing information about the specific invader. Should the same pathogen attempt to return, these memory cells swiftly recognize it and mount a faster, stronger, and more targeted defense. While some immune memories may fade gradually over time, others endure for decades, even a lifetime. This remarkable principle underlies the effectiveness of vaccines, which safely train your immune system to recognize and neutralize threats without causing illness. Your immunity is not merely reactive, it is adaptive, intelligent, and deeply historical. Every sickness you survive becomes an integral part of your vast cellular memory, a living record of battles fought and won. Your muscles generate tiny electrical fields even when you are at rest, revealing a constant state of readiness. Muscles perform far more than simple contraction. Even when your body is still, they produce subtle electrical currents that can be detected on the skin's surface using sensitive instruments. These electrical signals arise from the flow of ions across cell membranes, a process essential for maintaining muscle readiness and responsiveness. Electromyography, EMG, can measure these signals, providing valuable insights for diagnosing neuromuscular disorders or tracking muscle fatigue. The presence of this low-level electrical activity indicates that your muscles are always slightly active, not moving but poised to respond. Even during sleep, they hum quietly beneath the surface. Your body is never truly still. It pulses with microscopic signals, a quiet electrical whisper of life and readiness beneath your skin. Every heartbeat triggers a subtle pressure wave that reaches your brain, influencing neural activity in unexpected ways. With each contraction, your heart sends a surge of blood coursing through your arteries, not only as flow, but also as a pressure wave that travels throughout your body, including your brain. This pressure wave gently distends the walls of cerebral arteries, affecting neural activity in subtle yet significant ways. Recent research suggests that the precise timing of this pulse may influence perception, attention, and even emotions. While you don't consciously perceive it, your brain registers this rhythmic pulsation, creating a silent synchronization between heartbeat and thought. Your heart and brain are not separate independent systems. They are intimately linked, pulsing together in time, connected by blood, pressure, and rhythm. A quiet duet played out continuously throughout your life. And now a sense of profound quiet descends. The heart continues to beat, the lungs continue to rise and fall, but the questions arise more softly, the thoughts flow a little slower. Perhaps something lingered with you, a fleeting shape, a subtle feeling, a quiet trace of awe, or perhaps it's already fading like breath dissipating in the dark. That's perfectly all right. You don't need to cling to it to grasp and hold on. The body doesn't demand understanding, it simply exists. It breathes, repairs, remembers, adapts. It sustains you through stillness and change, offering rest and keeping watch as you drift towards sleep. Out there, the world continues its ceaseless turning. Inside, within you, vast galaxies shift, cells divide, currents flow, signals pulse in rhythms too small to name, too intricate to fully comprehend. Even in sleep, you are vast, a universe contained. So let your shoulders soften, let your breath deepen, let go of any tension you may be holding. There's nothing you need to do now. The body will carry you the rest of the way, its ancient wisdom guiding you. And so, under the quiet, watchful stars, the story continues. I hope you sleep well and dream softly. Good night. Music, 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 heat, music, heat, music, music, thank you, music, 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 thank you, music, 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 thank you, music, 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 heat, music, heat, music, 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 thank you, music, 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 heat, heat, music, music, thank you, music, 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 music.